Hello everyone. Hopefully you can hear me. I'm going to try to speak a little louder. I know during the Zoom sometimes can't hear quite as well. I'm going to work out a few problems. These are common questions that I get on the homework. I've had two people ask questions about separately about these problems, and so notice some of you already made hundreds on the assignments, so that just means that that's very impressive because it's really tough to get these right. So I'd really like to see you work on those to see if you work them the same way that I do. But we're going to start with 5.7. There's two problems on 5.7 that you have to do some algebra manipulations to. Just to be able to put it in a form where you're able to integrate. And so they're number 9 and number 10 on 5.7. And so problem number 9 is the integral of 6x over x minus 5 dx. So again, we're going to have to do some algebra manipulations because it doesn't fit, and that's squared, sorry. It doesn't fit any of our formulas because we have this x up here. So what I would do first, whenever I don't know what formula to use, or I think I may have to do some algebra to split it up. You know, this is on the section of natural logs, so it's got to have some kind of natural log integral in there, but there's not really a natural log integral that you can just see that you can do right away. So if I took the denominator here and I let it be my u, then my du would be equal to 2 times x minus 5 to the first power times 1, because the derivative of x minus 5 is 1. So I need an x minus 5 in the numerator in order to make this a natural log integral. Okay? And also, if I do use the du, which on this problem I'm actually not going to have to use, and you'll see why hopefully. But if I do use the du, then I have to bring out a 1/2 on that part. Okay, so I'm going to start by rewriting this. I need x minus 5. I have a 6 up here, so the 6 is going to go in front of the integral. And now I have x up here. I don't have x minus 5 in the numerator, but that's what I need, is x minus 5. So I can put a minus 5 here. All I have to do to keep equality is make another fraction and put plus 5 in the numerator and have that same denominator. So you see, if I was to put these two fractions back together, what that would do is that would, the 5's would cancel out, and I'd just have the x, and then if I multiplied the 6 in, I would have 6x. So I don't want to ever do anything that I can't go backwards, and I can always go backwards and get what I started with. That's what I'm trying to say. But I know I needed an x minus 5 up here to make it a natural log integral. And that's a natural log integral with this entire denominator being my u. But it just so happens that whenever I look and I need an x minus 5, well, there's an x minus 5 down here, so I'm actually going to be able to cancel out there, and that's going to mean that I can cancel the 2 out and just leave that to the first power. So now I have 6 times the integral of 1 over x minus 5. See, that first problem changed completely because I was able to cancel something out. Plus 5 over x minus 5 squared dx. So I'm not actually going to use the du because whenever I put this x minus 5 up here, it canceled something out in the denominator, and that made it into something I can integrate now. I know how to integrate this, right? If I have 1 over x minus 5, my u is going to be x minus 5. My du is going to be equal to 1. Okay? So that's just a natural log integral. Let's look at this second integral here. Alright, this is not a natural log integral. This is a U substitution integral. So I'd say u equals x minus 5, du equals 1. But I have to rewrite this because it has a squared. So this is going to be, this integral is plus 5 over u squared. So I'm having to integrate 5 over u squared. Well, I bring, so I have, again, I have to integrate each term. So that would be 5u to the negative 2. And then, so I'm integrating that. Add 1 to the power and divide by the new power. And you're going to get 5u to the negative 1. So it's 5 divided by negative 1. And instead of leaving my u in the numerator, I'll put it in the denominator, right? Because I don't want to leave a negative power. So this term is just going to become minus 5 over u. That's what the answer to that integral is. And u is equal to x minus 5. So don't forget the 6 on the outside. So I'm going to have 6 times, now this integral is the natural log of x minus 5, and then I figured, and I need absolute value bars, not parentheses, and I figured out that the integral here is negative 5 over u, so that's minus 5 over, my u was x minus 5. Alright, and then I have plus c. Now, that is the correct answer. You can multiply the 6 in if you want to. And if you do that, then you would have 6 times the natural log, the absolute value of x minus 5, minus 30 over x minus 5 plus c. Alright. Now, it's not the hardest problem, but that is kind of it's different because you have to do all this algebra before you can actually do the calculus. And the next two problems you have to do the same thing. So let's look at number 10. It's a little tougher. It actually took me about 5 or 6 minutes to look at it and figure out exactly what I needed to do just to put it in a form that I could work with. So if you got that one right, which some of you've already got hundreds in your homework, so I know you did, then congratulations. That is a very big feat mathematically to get this one right. And if you have another way to work the problem that I'm showing you right now, please share it with me because I would like to make this problem as easy as possible, and it's not an easy problem. Alright, so I have the integral of x times x minus 4 over x minus 2 cubed dx. Alright, so I was really stuck. I know one way to work this problem that we haven't covered, and we don't cover until chapter 8, but I was like, well, I can't use that method, and it's a very long process as well. But I can't use that method because we're not in chapter 8. We're still in chapter 5. So that was the first thing that I had to tell myself is I can't use what I want, the method I want to use. So what I did first is I multiplied this x times everything in the parentheses. And when I did, that gave me x squared minus 4x. Okay? And then the denominator was x minus 2 cubed dx. And so I said to myself, if I can, it's probably going to be some type of natural log integral. It's got to be there because this is on natural logs. So what I did is I took my entire denominator. I took my entire denominator as my u, and when I do that, I will have x minus 2 to the third power, and then that would make my du equal to 3 times x minus 2 to the second power. Okay, and so I wanted to see, well, what would I get if I squared out x minus 2 and just leave that 3 on the outside? So if you square x minus 2, remember you got to FOIL that out. So that's going to be x squared minus 4x plus 4. And once I saw that, then that's whenever I said, well, x squared minus 4, I have or x squared minus 4x is in my numerator already. I would just have to put this plus 4 up here. And if I put the plus 4 up here, then that's going to make that a natural log integral where the u is the entire denominator and the du would be in the numerator. I would just have to adjust for the 3 on the outside by moving out a third. Alright, so once I saw that, then I said, well, let me rewrite this. And I'm going to have to do a little tricky algebra, because if I do put a plus 4 right here, that means I'm going to have to put a new fraction with a minus 4 out to the side. Alright, so that would be x squared minus 4x. And again, I'm going to put a plus 4 there, because if I put a plus 4, then that means that it's a natural log integral. So this first part is going to be a natural log integral where my u is equal to x minus 2 to the third power. Alright, but I can't just make up that 4. If I add 4, I also have to subtract 4 and keep that denominator of x minus 2 cubed. Alright, and so it's okay to do that because I know what this is. This is a U substitution integral. This is, u is x minus 2, du is 1, so I would be integrating 4 over u cubed, and I can do that, or 4u to the negative 3 power. I can do that. So what I've done is, I've made the first integral, I put it in a form where it's going to be natural log, but I do have to bring out a 1/3. The second integral is just going to be a U substitution integral. So it's going to be one of the easier integrals from one of the previous sections. Alright, so I'm going to start out and I'm going to put, remember, we've already done this integral basically because I put the du in the numerator that I need. So the only thing I had to remember was that 1/3. So I got to bring out a 1/3, and then it's natural log, and all of this stuff on the bottom is my u. So it's natural log of x minus 2. Oop, I need to make sure that I cube that. So it's x minus 2 cubed, like that. Alright, so that's my first integral. Now my second integral, remember, the u is equal to x minus 2 and the du is equal to 1. So over to the side I'm going to do this integral. It has a minus in front of it as well. So it's the integral of negative 4 over x minus 2 cubed, or we said that it's a U substitution integral, so it's going to be the integral of negative 4 over u cubed, or du, because our du was 1. Alright, so that's equal to the integral of negative 4 u to the negative 3. So when you add 1 to the power here, that's going to become a what? That's going to become a negative 2, and you'll divide by negative 2. Okay, so that's going to be negative 4 u to the negative 2 divided by negative 2. Alright, so that's going to be just what? Can you tell me? Hopefully you can. That's just going to be equal to plus 2 over u squared. So it's going to be a positive 2 over u squared. And my u, remember, was x minus 2. So I have plus 2 over x minus 2 squared. Alright, and then plus c, of course. Gotta put that plus c in there. Alright, so by doing a little tricky algebra, I was able to break that up in a way so that I had a natural log integral, right? I had this natural log integral here, and I had a U substitution integral. And that's really the only way that I know how to work that out without using some more advanced methods. But still, the more advanced methods would probably take me just as long. Alright, so the last problem I'm going to cover in this video is from 5.8, and it's problem number 4. That's pretty tough. I didn't have a chance to do one of these in the Zoom video. In the video I made you for the class, there may be one there. So I might would watch that video. It should be one there. If it's not, that's bad on my part. I should have put one in there. The problem is it's kind of set up so that we would have, it would be, and of course this is the section on inverse trig integrals. And so it's kind of set up like an inverse trig integral. It would be an inverse trig integral if we didn't have the x up here. If we just had the minus 4, then it would be arctangent integral. But our problem is we have an x, minus 4. And so most people, what they'll do is first they'll try to break it up into x over the denominator and minus 4 over the denominator. And that kind of works. For the second part it does, but for the first part it really doesn't. So what I did on this problem is I looked at my denominator and I want to see what all this is actually equal to. So square this term and you get x squared plus, well, that'd be 4x, then it's going to be plus 4 plus 16, so that's plus 20. Alright, and so if I let that be my u, my du would be 2x plus 4, or 2 times x plus 2. So for this to be a natural log integral, which is what I'm going to start with, and you'll see we're going to get a natural log integral out of this, and we're going to get an arctangent integral out of this. And hopefully you'll see how. I want to put an x plus 2 in the numerator. And of course with that integral I'll have to adjust and bring out a 1/2. But I want to put an x plus 2 in the numerator. And I have x minus 4. Well, I can put an x plus 2 in the numerator so that I'll have a natural log integral. And remember, it's x squared plus 4x plus 20. And I can put a plus 2 there as long as I make another fraction. And whatever fraction I put, if I was to go backwards, I'd want to get back to x minus 4 in the numerator. So I have to put minus 6 over, and instead of writing this, x squared plus 4x plus 20, I know that that is a natural log integral. I'm going to write the original denominator, because anytime I have a constant in the numerator, and then I have a variable squared like this, and I have a constant squared, that's an arctangent integral. Okay? So again, if I needed to go backwards, sorry about that, if you're unsure when you split it up, that you split it up carefully, that you split it up the right way, remember when I put these two fractions together, and these denominators are the same thing, all I did was square that and add 16 to get the 20. Alright, They are the same thing. If I was to put these two together, the plus 2 and the minus 6, when I put them together, would give me the minus 4. So we need to always check and make sure whatever fractions we come up with, if we put them back together, we get what we started with. Okay? And so I know this first integral is a natural log integral because I set it up that way. I put the x plus 2 up there so it would be a natural log integral. I just need to bring out a 1/2. So that's going to be 1/2 times the natural log of the absolute value of x squared plus 4x plus 20. Alright, now this second integral is going to be an arctangent integral. Alright, so my u is equal to x plus 2, so my du is equal to 1, which is what I want, because I have a constant up here, no variables. And then my a here, don't forget you got to take the square root of 16, my a is equal to 4. So before I start using my arctangent formula, I need to write a -6 in front, because that is in the numerator. The negative here means that 6 is negative. Alright? And then I follow my arctangent formula. It's 1 over a, so that would be 1 over 4 times the arctangent of u over a. Remember, u is the thing being squared, so that's x plus 2 over a, so that's 4. And then plus c. Alright? And so I might clean this up a little bit by, you can simplify your fractions there. So my answer is 1/2 times the natural log absolute value of x squared plus 4x plus 20 minus 3/2 times the arctangent of x plus 2 over 4 plus c. I hope that helps you out. Those are some of the harder homework problems. I do have your test ready, so make sure you take that by tomorrow night. The way that I set your test up, you'll be able to work each problem twice. So you have 2 submissions, and I just grabbed homework problems. So hopefully you've been taking good notes, and your test won't be that big of a deal. But I will see you in the morning, bright and early at about, well, it's not too early, about 9 o'clock. Let's go ahead and have another Zoom meeting, because I do need to go ahead and move on to new material. So I know you have a test that's due tomorrow, but that's just the way, that's the nature of the beast. We got to get that done. We got to hurry up as fast as we can, because it's a race to the end now. So, alright, thanks for watching the video. If you have any other questions, send me emails. Have a good day.